All right, 12.5 notes here. Let's imagine that we are looking at a regular polygon. Trying to recall if last semester we did much work with regular polygons. I don't recall that we did. We may have talked about the meaning of the word regular, meaning sameness. And so, therefore, a square, for instance, is a regular quadrilateral because all four sides are the same and all four angles are the same, right? You can have a quadrilateral that has all four sides the same, but not all four angles the same. That would be a rhombus. Rhombus is not a regular quadrilateral. Likewise, a rectangle has all four angles the same, but not all four sides the same. So it is not a regular quadrilateral. So a regular polygon has all sides congruent and all angles congruent. So there's a regular polygon illustrated here. And if it's regular, as the text says, I'm just reading now, then its area can be divided into a bunch of congruent triangles, each one looking like the one shown at the right. So I've sort of carved out one triangular area out of this regular polygon, and there would be a bunch of other triangles coming from the center, all congruent. So that one triangle's area would, of course, be equal to 1/2 times b times h. That's the formula for the area of a triangle. The b is illustrated here. The h is also shown. Now, if the polygon was regular and it happened to have 8 sides, if it was an octagon, then there would be 8 of these triangles, and the total area would be 1/2 times b times h times 8, because there's 8 of the triangles. But if the polygon had 10 sides, if it were a decagon, the area would be 1/2 times b times h times, whoops, that's supposed to say 10, not 8. Well, if the polygon has some number of sides that we don't know the number, let's just call it n sides, then the area of the polygon would be the area of a single triangle times the number of sides or the number of triangles that you could carve out of that polygon. Right? So now, because all 4 of those terms, the 1/2, the b, the h, and the n, are all just being multiplied together, we can change the order of the multiplication, and we can get rid of the parentheses or put the parentheses anywhere we want. It's really not going to make any difference. So I'm going to rearrange it like this. Just move the parentheses a little bit, change the order of the n and the h, just because of what I want to talk about next. And again, that would be a formula area for any regular polygon, from 8 sides to 10 sides to 1,000 sides to 1,000,000 sides. Okay, well, if you're talking about 1,000,000 sides in a polygon, that polygon, you wouldn't be able to tell if that was actually a polygon with 1,000,000 tiny little sides or if it was a circle. You probably would think it was a circle. The sides would be so small and the angles would be so large and so not sharp. It might just look like a circle. So let's just suppose we're dealing with an actual circle. Okay. In that case, what we were calling the h up in this diagram up here, which is the distance from the center of the polygon to a side of the polygon, in that case, we could call that distance something else because we have a word for that distance from the center of a circle to the edge of the circle. What is that word? It's not diameter, it's radius, right? Okay, some of you knew that. It's radius. We could call that the radius. So instead of calling that h, we could call that length r. Oh, I mean, we can call it whatever we want, but it's usually helpful to ascribe letters to things that have some connection to the word that they stand for. And now let's also go back up to the polygon briefly. The b times n part of the formula for the total area of the polygon, which I put in parentheses, that's the length of one side, which is the b, times the number of sides in the polygon. That's what the n stands for, the number of sides in the polygon. So if we're multiplying one side length by however many side lengths there are, there's a word for that total length around the polygon, the length around a polygon. What do we call that? We call that, begins with P. It's the perimeter, right? The perimeter of the polygon. But in the circle, we have a different word, a unique word for perimeter of the circle. It really means perimeter of the circle, but the word begins with the letter C, and you know what it is, right? It's the circumference of the circle. So if we take this area of a regular polygon formula, and we just keep increasing the number of sides in the polygon, more and more sides, getting smaller and smaller until the thing is indistinguishable from a circle, then we can call the b times n, which is the perimeter of the polygon, we can call that the circumference of the circle, and we can call the h, which is the height of each little triangle, we can call that the radius of the circle. And so here's a formula for the area of a circle. Now, I'm sure you don't recognize this formula. You've probably never seen it before. And that's because we can turn this formula into something a little simpler and something that is more familiar to you, I'm sure. Recall that circumference itself has a formula. What is circumference equal to? You remember that? You were just quizzed on it. It's pi times the diameter. So that can all replace the circumference, but then we still have an r left over. So here's a formula for the area of a circle, which I'm sure you also have never seen before and are not familiar with, because we can still keep turning this formula into something more familiar, right? All these terms are being multiplied together, so we can just change up the order of the multiplication, can't we? It doesn't matter what order we multiply things in. So I'm going to put the 1/2 and the d next to each other. I'm going to put the pi out in front. I'm going to put the r out here. Now I ask you, what is 1/2 of the diameter of the circle? That 1/2 diameter can be replaced with something a little bit simpler. What is 1/2 of a diameter? It's the radius, isn't it? So this formula turns into this formula, which turns into pi r squared, because r times r is r squared. This is a formula I imagine you are familiar with. You probably were taught this formula a long time ago, and this is where it comes from. Okay? You were probably just handed this formula a long time ago by somebody who said, look, here it is. Just believe me, here it is. Let's use it. Let's find some circle areas. But, formulas always come from somewhere. They don't just come out of someone's imagination, okay? So here's an explanation for where the formula comes from. It is different from the circumference formula, which is pi times diameter, or as I saw a lot of people writing on the quiz, even though I never mentioned this, a lot of people were writing 2 pi r. That's legitimate. I have no complaint about that. Just makes me think that people are spending not so much time watching my videos and spending their time looking up stuff online. I don't know why you do that. I don't think you can learn stuff faster through other people's lessons and other people's videos than you can through mine. I seriously don't think you can do that. But anyway, why is this legitimate? Because 2 times a radius is equal to 1 diameter, right? But look, this circumference formula and this area formula are really importantly different, okay? 2 times r is not the same as r squared, which is r times itself, or r times r. That's not the same as r times 2, okay? And believe it or not, I had a couple people on the last quiz who were using this formula on the quiz when we had never, ever talked about areas of circles. And that, again, leads me to suspect that people are not watching my videos, not doing my homework assignments, but just looking up stuff online and kind of randomly applying it to the stuff that I'm giving. People who use this formula got 0 credit for any problems that they used that formula for. Okay, so let's move on and solve some problems using not just this formula here. Here it is for the area of a circle. But here's a second new formula you're going to have to deal with in this lesson. This formula is for a fraction of a circle. Look, just like we have this formula, arc length, which is part of the circumference of a circle, its formula is expressed by this fraction times the circumference. That's what an arc length is. It's a part of the circumference. Well, when you think about fractions of circles, remember how you first were taught fractions in grade school? You probably learned about fractions at some point by teachers giving you pictures of circles with pie pieces cut out of them, right? So this formula here, which is the formula for a fraction of a circle's area, see that part of the formula is the entire circle's area. If you multiply that entire circle's area by this fraction, you'll get the area of that pie piece there. Okay, so you've got these two new formulas to deal with. Let's apply them to these three problems. These three problems are incredibly straightforward. Many of the problems in the homework are like these, but there are some problems in the homework that are not as straightforward as these. You shouldn't be shocked when you encounter a problem in the homework and you're going, wow, that doesn't look like any of the problems he showed us in the examples. That's what an advanced class is about. But these are very straightforward. To give me an excuse to just say to you again, begin the problems by writing down the appropriate formula that might have anything to do with solving the problem. When it says area of a circle, write down the area of a circle problem or formula. Area is equal to pi times r squared. Now plug stuff in where it belongs. Do we have a radius in this diagram? Yes, we do. It's 24. So area is equal to pi times 24 squared. I asked for the exact area. So do not punch the pi key on your calculator or put 3.14 into your calculator, but do the 24 squared. That'll get you 576. And so there is the area. The units would be, of course, square centimeters. Do not put that 2 exponent next to the pi. That would be wrong. Don't put it next to the 576. That would be wrong. The exponent only goes with the centimeters, okay? We already applied that exponent to the 24 to get the 576. And we should not be squaring the pi. That's not what the formula says. The formula only says to square the radius. So once we've squared the 24, that square shouldn't appear among the numbers anymore, only by the units. All right? So that's about as easy as these kinds of problems come. But then we were also asked to find the area of the shaded sector. Well, I forgot before I made these notes to shade this sector. And by the way, that word sector is a technical geometric word, and it basically means a pie piece. I'm not going to quiz you on the meaning of that word, okay? But I want to be able to use it when I'm talking in these video lessons or in class. I want to be able to say sector and not have people go, what is he talking about? And suddenly get lost and not hear the next 2 sentences that I'm saying because you don't know what the word sector means, okay? So if this were a quiz or test, of course I would have shaded this for you, right? And so here's the formula we need for a sector. Write it down without plugging anything in. Theta over 360 times pi r squared. Now plug things in. Do we have an angle measure? Yes, we do. 105 degrees. So plug that in, 105 over 360 times pi. Plug in 24 for the radius squared. Now put all of this in your calculator, but don't put the pi in there. Okay, so 105 divided by 360 times 24 squared, that's 576 times 7/24. And so that's going to be, I'm going to say 168 pi square centimeters. If I did all that arithmetic in my head correctly, I'm pretty sure that I did. Okay, you can check me with a calculator. All right, write down the formulas, then plug things in. So number 2, a circle. See that keyword circle? Oh, and that word area, it doesn't say circumference, it says area. So we got to use the area. If it said circumference, then we don't use the area formula. Use a circle as an area. Write down the area of a circle formula. Now plug the information in that we've been given. Where does that go? Where does that 200 go? What is it? It's the area, right? So plug it in there. 200 equals pi r squared. It says find the diameter to the nearest tenth. Okay, so we don't have to worry about exactness here. We can replace pi with a 3.14 if we want to. Well, oh, wait a minute. It asks us to find the diameter. We don't have a diameter in this formula, but we do have a radius. And come on, if we can find the radius, it's a really simple step to getting the diameter, right? So let's solve this for the radius. Now it's clear we have some algebra to do. In the first problem, for both the circle area and the sector area, we didn't have any algebra to do. We plugged everything in where it belonged, and we looked at it and went, no algebra, just simplifying. This time, we've got some algebra to do. We've got to solve for r. Now, this is going to require a step that, were we doing this in Pythagorean theorem work? Sure, we were. We're going to have to take the square root of both sides eventually, but not yet. First thing to do is to divide both sides by pi. Okay, and so r squared turns out to be, oh gosh, I wish I had worked this out in advance or looked up my notes from last year. 200 divided by pi is going to be something like, I'm just going to estimate here. And please don't anybody get hung up on this or the fact that this is going to be a little bit off. 65 times 3 is 195. It's going to be a little less than 65. I'm just going to go 64.3. I don't know. Okay, 64.3 approximately. So then take the square root of both sides. And we get r was equal to, well, 8 squared is exactly 64. So let's say that comes out to just a little bit more than 8. Let's say 8.1. Okay. Finally, once you've done your algebra, gosh, this is important. Are you listening? Because this is such an easy thing to forget to do. Right? If you're being real good, if you're doing what I'm telling you, and you write down the formula, and you're patting yourself on the back because you're going, I'm not going to make a mistake here because I'm writing down the formula like Mr. Nortillo told me. And then you plug the number in the right place in the formula, and you pat yourself on the back one more time. You go, I put the 200 in the right spot. I didn't put it in for the R, put it in for the A, and you're feeling really good. And you say to yourself, now all I got to do is some algebra here to solve for R. So you solve for R, you're really confident you've done everything right. You're so happy, you circle that. In your mind, you're thinking, exclamation point, I got that one right, and you move on to the next problem. What's the trouble? You didn't answer the question. You've done everything right so far. You haven't done anything wrong. You're just not finished with the problem. Just because you've solved the equation for the variable doesn't mean you're finished with the problem. It's such an easy thing to forget to do this one last thing. Go back and reread the problem and double check that you have the answer to the question. Okay? The question was find the diameter. We haven't found that yet. Okay? I mean, it's an easy step to finding the diameter, just double the radius, but it's also so easy to forget to do that. Okay. All right, last one. The circumference. Oh, see, circumference of a circle. That probably means we're going to need the circumference formula. So I'm going to write that down is 28 pi. Find the area of the circle. Wait, is this a circumference problem or an area problem? The answer is yes, it's both. We're going to need both formulas. Not at the same time. Okay, but what have we been given? We've been given the circumference. So where does that go? It goes here. 28 pi is equal to pi times the diameter. Solve that for the variable by dividing both sides by pi, and you get diameter is equal to 28. Circle it, exclamation point, you're all excited. Duh! Did we answer the question? No. We've been asked to find the area of the formula, which again is why I encourage you to write down the formula or formulas. If you might need two formulas in a certain problem, write them both down at the very beginning. Okay? Because if you do that in this problem, you're less likely to circle this answer and be satisfied. Okay? You're going to know if you wrote down this formula here at the beginning of the problem, that when you get here, you haven't finished the problem. Okay? Now to find the area, we need a radius. We don't have a radius, but we have the diameter. So the radius is really easy to find from that. Just cut the diameter in half and then plug that in. Area is equal to pi times 14 squared, which is 196 pi. I asked for an exact answer, and that is the exact answer. It's an area, so it would be square centimeters. Okay. Again, in my opinion, these are very straightforward problems because in every problem, the key words appear that enable you to identify the correct formula to write down. Just write down the formulas, just plug the numbers in where they belong. And then if you have no algebra to do, you just simplify the result. If you have some algebra to do, it's pretty simple algebra. The last thing in each problem is once you've solved the algebra, make sure that the result actually answers the question that's being asked. If it doesn't, you probably haven't done anything wrong, but you may have to take an additional step or two to solve it. And so a lot of the problems in the homework, as I said, are like this, but make sure you're using the right formulas, okay? And then some of the problems are going to make you think a little bit, as they should. All right? Good luck. We'll see you next time.